Hey guys, welcome back to my channel and let's solve today's new problem 2485. Find the pivot integer. Okay, so let me explain the question instead of reading loudly what the question is saying in English. Okay, suppose I have a range. Let me use the black. Black is always good. 1, 2, 3, 4, 5, dot. Okay, now I have to return a number. If I choose this as a return value, then the sum from 1 to 5 will be equal to 5 to n. Understood? This is the main problem and I have to return a number. Okay. And if you do a simple math, then from 1 to n, you can only have one value, either 1 or none. Okay. Either 1 or none, whose sum of left equals to right, and that number is included in this. Okay, understood. This is the main question. So how can we solve this? The most fruitful thing you can also think of is, suppose I have a range till I can say 8. Okay, 5, 6, 7, 8. Now, what you can do is, if you do a simple brute force, then you will go from I to j, and suppose I have I and j, you will sum this up. Then from j to n, you will sum this up. Okay. And if they are equal, then you will return 4. Okay. Understood. But what will the time complexity of this? You are using from 0 to n for this j how many times? Then you have to find the sum also, then write sum. This is going to be n square or more than that. Okay. And I don't need that amount of complexity in this easy problem. Is it easy? Yeah. Okay. So how can we do that? If you have done a prefix sum, then you would know that. Suppose I have a range from this, a simple logic. Okay. I have this range and I know the sum of this range. Okay. Now, okay, suppose the sum is x. Okay. And I cut this in this portion and I know this portion of the sum. Then can I find this portion? If I know the whole value is x and y plus some value, then what I can do is x minus y would be that value. Is it or not? It will be. So I have the whole array sum and the left sum. And can I find the right sum? Yes, you can easily find that. Okay. Understood. Now, what can I do is simple. If I do is I will go from this portion, and what I do is let's write the logic. First, I will find the sum. Okay, let's find the num as equals to 1 till 8. Okay, and what it would be? It would be 36. Okay, I use calculator just to be right. Okay, now what I will do is let me drag this a little bit here. Okay, now I will go from this portion and keep on going, and suppose this is my I. So I am keep on adding a value in a prefix sum. Prefix would be 1 plus 2 plus 3. Okay, now I got the value as 3 plus 4, 6. Now what I will do is 36 minus 6 equal, if I have this value as 6, then this value would be my 30. Okay, but I have to include 3 here. I have to also include 3. Then I will plus 30 plus 3. Okay, this is the main concept behind this. Okay, so let's code this up. Okay, This I will go for more better approach, okay, in which I'm going to use binary search. Okay, but for that, let's use this concept. Okay, I need some whole sum. It would be uh, 0 for I in n, but I in range 0, 1 to n plus. It was in Python and it excluded, so I had to use n plus 1 for inclusion. Okay, then so the whole sum would be I. Okay, now I have found the whole sum. This is the sum of whole range from 1 to n, and the square bracket means it 1 and n are included. Okay, I have found that value. Now I need a left sum variable for I in range 0 to n plus 1. Okay, I don't need 0, I need 1. Now what I will do is let's I need to include the left sum. Okay, so then left sum would be left sum plus I, and right sum would be whole sum minus left sum, but I have to include the pivot point also. I also. Okay, now if left sum equals to right sum means I got the point, then I have to return I. And if whole for loop keep on going and it ended the for loop, then I have to return minus 1 because I didn't get any point. Okay, understood? Yeah, and the textures are getting passed. Now let's try to accept this. Yeah, it's being accepted. Okay, so now this is a time complexity of n. Maybe what is the time complexity of this? N for finding the sum and n for iterating over. So it would be 2n. And space complexity is one kind of, because I'm not actually using any more variables. Constant, so it would be one. Okay, now how to do more optimal approach? Sorry for the bad handwriting because I cannot use a mouse to read. Okay. So what can I do is I know a formula which calculate me the sum from 1 to n, and it would be n into n minus 1 divided by 2. Okay, this sum can give me, cannot, no, it's not can, it will give me the sum from 1 to n in time complexity of E1, constant time. So why cannot use this? Instead of finding the sum, whole sum, I can use n thing. So it could be, right? So let's define our function. Def, I'm going to use binary search in soon. Okay, now let's sum s of n equals to return n into n minus 1 divided by 2. Okay, this will return me the sum of n. So sum is n plus 1 because in this n is not included. Okay, so I found the sum in a more better way, and this will return me a much higher complex. I have that better. Now I have to use binary search in this. Okay, so how can we do that? Suppose I have 1, 2, 3, 4, 5, 5, 6, 7, and 8. Now, in this, I move to a center. Suppose I get this value. Now, what is the sum from 1 to 4? I can find in a time complexity of 1. Literally 1. 4 plus 4, 5, 6, 7, 8, 9, 10. It's giving me 10. Okay. Now, I have already found the sum of whole value x. Now, what I can do is I can find this range using x minus 10. Okay. Understood. But I have to include 4 in this pivot point. So it would be I. And 10 would be replaced by L. And x would be replaced by whole sum W. This is my formula for finding the right. Okay, I can easily find the left with this. Now, I check 10 and what is the sum of this? 8, it is 16, 20. So it's giving me 37. From this to this, it is giving me 37. But I have 2 plus 4 also. So it would be giving me 41. Now, which is greater? Is left is greater or right is greater? You will say right is greater. Then what I'm going to do is I'm going to remove whole this function and move this. And I'm going to put, first of all, I was here and J was there. Now I will put I here and J will remain there. Okay. Now, I'm again finding the value of this and this with inclusion of this. Now I will again check which is greater than. If I got a value, it will be nice. Then else I will move forward. I will move forward and I'll put I here and J here. Sorry. I was here, so I'm going to put my left here. It would be like this. Okay, keep on like this. So let's go to this. So I need I comma j equal to 0 comma n. Okay. So now I am going to use a while loop where it would be I less than j. Now I have to find the mid. So it would be I plus j divided by 2. Okay, now I have to find the left sum. Left sum would be sum is, and it would be mid plus 1. Because in this formula, n is excluded. So I have to use a mid plus 1. Now, how will I find the right sum? It is so easy, just the same, so easy, beautiful, plus mid. Okay, now I'll check if left sum equal to right sum. If it is, then return the mid row. Else, I have to check the condition. Where should I move the I j? If left sum is greater than right sum, then what I will do? Just simply move I equals to mid plus 1. Else, j equals to mid minus 1. Else, return minus 1. Simple. Okay, if an equation 1 matrix is falling off, can I put close to here? Then don't give me a clear Let me accept it. Let's submit this, submit this, submit this. Yeah, it's been accepted and better than okay. It is an n log n it's a simple log n complexity. Okay, well, really a one complexity, time complexity, and space is only one. Okay. Hope you understand this concept. If you do, just give it a like or subscribe. Okay. See you.